Okay.
Okay, so this is session 2, and this is the 1 o'clock session, or 1:09 session. So we've just been discussing what we're going to do in this one, and that this class will essentially build a VI which will analyze a stack of images instead of a single image, and we'll kind of step through how to construct it together. So, as you would expect, we need to run Labview, because you do. And hopefully everybody has at least this little camera thing and these two. You don't necessarily need this little switch on the left. But once you've got a Labview...
Do you choose that? Or because
it depends on the packages you've got installed. So I have a few more packages than you have to install. So. Okay, so we got a file, a new VI, and then you should have 2 screens. And if you have Windows 7, you can kind of stretch it, so you grab the top and put it to the side, and then you can see both sides at the same time. Makes things a little bit easier, the layout. If you don't, then kind of stretch it to the... If you're still running Vista, then we have to stretch it. Okay, so we need to step it through. So the first thing that we have to do is, as you can see, on the diagram, if you have the diagram handy, is we need to tell it where the files are, and we need to put them in the memory. So the first thing we need to do is, if you right-click on the front panel, so everyone right-clicks on the front panel, you have this little thing pops up with all your controls. We then want to go to text controls because we want to enter a file path. So you have numerous ones, just
even if it's an image, you still, it has nothing to do with you are picking an image, or
no,
the text.
So this is just a. I have to get a file path from somewhere, and what we can do is, from the first class, one thing that we can do is go to File, Input, Output, and go to Advanced, and then we can use what's called a file dialog, and then that will ask us. As soon as we run the VI, it will say, "Where's the file?"
No, but my question was: this text concept has anything to do with your file extension? No.
At this point, all it's doing is we're putting a box that writes some text. How we define that text means nothing. It's just we have to have a box which defines some text.
Wait a second, because I was confused.
That's fine.
Text and which one?
So if you right-click on the screen, go to Text Controls, and then because we want to put a file path, we choose File Path Control. We don't have to. We could use what's called a string control, but then we have to use a string modifier to change that to a path name. So if I do it the other way and click on string, and all that is just regular text. It has no other identity other than text. But if I want to use this for a path, then I need to also change this string to a path identifier. So I would then have to right-click on here, go to String Controls, and then I would have to convert it string to path. And then so if I then did that, I could wire that up, and then the output here is path, just like the output here is path. The times when you need to use this are when you've got things going on within your VI. If you're having to write particular things, or if you're coming up with a new file name, you would use this kind of a thing where you make the user or yourself type in a name, and then it converts it to a path for you in the program. Because we actually need to choose a file, using this path dialog is much more efficient. So we have this path thing, and as soon as we put it on this right-hand pane, it would have shown up on the left-hand pane, because this is the block diagram version of this. Okay, so we have our path to a file. Okay, we now need to put a picture in there, because we need this path is essentially to a picture, so we now need to put a picture in there. So on the block diagram, we need to go to our vision tool pack, So if everyone goes to the vision, and in the top of the grey box, you'll see this kind of little pin. And if you hover over it, it's basically a drop pin. So if you click on it, if you right click, so if you click there,
I hear John. Vision. Okay.
so if you click on the pin, you essentially anchor this toolbar. Because we use it a lot, it's generally good to just keep it open. Because if you just right click on the screen and you have this regular tool panel, this little pin is open, which means it'll go away if you click on the screen. If you click the pin, you notice you don't have this pin in the corner, because now it means this one's permanently open. And you can do it with all the tool palettes. If you say you use the numeric one a lot, you can drop the tool pan there, and then you can have this one permanently open too. It's just a way of, if you use certain tool palettes a lot, you can just keep them open. Okay. So we need to do two things. We need to make space in the memory, and we also need to put the file that we chose our directory to an actual image. So
we have to do the first and the second before.
I mean, yes. I mean, in the
process. So you first should create the memory.
In the process, you have to create the memory. You can put it down in any order you want. It's a little bit different from regular programming. We're not limited to having a linear program. We can restitch the order whenever we want to. So if we go to image management, so vision utilities, everyone clicks on vision utilities, and then goes to image management. Okay, your toolbar should look like this. Yeah? Ilona?
Yes.
Yeah?
Yeah, kind of. A little bit different, but it's the same.
You're clicking around. I just want to make sure we're on the same page.
Yeah. I just a little bit different click, but it's okay.
Okay. So we want to create this. So if you click on iMac Create and just put it on you should be able to just click on it and move it over. Yeah, and then just click on the screen where you want to put it. Just stick it wherever. Does everybody have an iMac on?
No, they don't. It's rooms.
Okay, I have that.
Yeah? Okay. So we now need to give this a name. So if you hover over it, you'll get all these kind of colored dots which come up, and the image name is just up here. So we hover over this little dot, we have a little wire spool, and if you right click, then you should get this list pop up. Go to create and constant. Okay? Everyone should have something called untitled. And you can just go ahead and rename that whatever you want to. ROI image. It doesn't really matter as long as it's a unique name. The other thing we want to do for completeness is to tell it.
So can you tell me basically what did you do here? Or
just gave it a name.
Okay.
Because
but it doesn't know still that it will open this.
Nope, we're not up to that point. All we're doing is iMac, it stands for Image Acquisition Buffer. We essentially now have created a tool which will make a space in the memory, and we've given it a name. We now need to give it a type. iMac almost always defaults to grayscale, so 8-bit images. And because we're going to be looking at color images, we want to tell it to expect a color image, because it depends on what type the image is. That sets how much memory to keep, because a color image takes up a lot more room than a gray image. So we need to tell it that, look, you could expect a color image. So if you right click on this little one which says image type, and this time instead of going well, you could go to either. If you go to control, on the front panel you'll get a little choice menu, but we don't want that. So we want to use constant again. But instead of choosing a name, we get the little drop down thingy. So you want to click on this little arrow, and we want to say, okay, we want to use an RGB U32. That's just a color. That's a color image. The U32 stands for unsigned 32-bit integers. standard
How
color
can we
image.
like distinguish if it's U64 or U32?
So a U64 is a, I think it's what it's a 10-bit or 16-bit color image. It really depends on what you've got. You don't have any cameras that will output it.
Ah, okay, good.
So the only things that you will use are U8, U32. If you have on the big Andor camera, that has a higher bit depth, so then you would need to use a U16 because that has a 16-bit.
Which one is that? The fast speed?
No, the Andor camera. So the single molecule. No.
Ah, the one
big,
in the okay,
right.
okay.
So that's a 16-bit detector. So there you would need to use U16.
Okay.
But other than that single example, you'll only be using U8 and U32. There are some occasions that you'll use HSL, which stands for hue, saturation, and luminosity. And I will touch on it if I show you a color change example. The problem with red RGB images is that they don't contain any information on intensity, which is not changing the color. So if you take an RGB, like all the false color images that you get from the confocal are hard to work with because they're RGB values. So as you go from light to dark, it changes colors other than just the red. Just because of how it represents.
Okay.
Hue, saturation, luminosity images, the hue and the saturation set the color, and then that third integer, so the luminosity value, sets how bright to make it. So
within just one single color.
Exactly, exactly. And an RGB doesn't have that option. It uses all three in together to actually change the intensity. So HSL is good for if you're trying to display some images. You can run a conversion in the program back to RGB so that computer screens can read it. But HSL is good for manipulation of intensity. Anyway.
So how could we know the quality of the image? What kind of image maybe?
So like I was telling Eric, basically you're only ever going to use U32 or 8-bit grayscale. Okay. You don't have any cameras other than the Andor that do anything else. And if specific examples you might come across and you'll have to adopt for them, but there aren't any examples that come to mind. If you're using a camera that's color, it's U32. If you're using a black and white one, it's grayscale, 8-bit grayscale.
So we cannot get any information from the image itself, and we can only get it from the equipment, right? Yeah,
I mean, technically you could get it from there as long as you were going higher than the maximum amount. So if you go to an image and see you have, numbers which go from 0 to 255, then that's 8-bit. Because 8 bits are 256 levels. And if you split apart a U32 image, each channel, each color channel contains, 8 bits of information. So it goes 0 to 255 in each of the colors. But if you're never going, so if you're doing the image correctly, you'll never ever get to 255. So on those images, you have no way of knowing. So a correctly made image, you should never have the maximum value, because it means you're losing information. Because you don't know if that should be 255 or 256. But if it was going to, let's say, 252, you didn't reach the maximum sensitivity of the camera, so that is a correct image. If you go to 255, you don't know if that's 255 or 10,000, because you don't have any quantification. Yeah. Anyway, so we made an image. We say it's going to be an RGB image. Now what we need to do is, open the actual image. So if we go up, change palette, in other words, and we go over to files, and we click on that one, then we want to read a file. So we click on that and drop it right next to it. If you hover over, you'll see you've got, a lot of dots again. We need to wire this file path into this one. So if you click left click, here, and just drag the file thing down, make sure you're hovering over file path, and then you shouldn't get any errors. We okay? Hello?
Yeah. Fine.
Okay. Okay. So what we need to also do is tell it, okay, we need to use this memory location and wire that new image into this thing that says image. What we're telling it is where to put this image that we're reading from this file path. Okay? Yep. Okay. Now these, like I showed in the first thing, these will run in order. So if we ran this right now, whoops. If we ran this right now, because we can, it says you can run it, totally fine. This will run first.
But what is the output?
Nothing. You don't have to wire an output for it to have no errors.
Okay. That's what you,
Yeah,
why you run it, to see if there are errors on it.
Yeah, I mean, the nice thing, you know, if
But doesn't it pop up automatically?
yeah, so if I do this, and I, you know, accidentally wire this to the wrong type, I don't know, let's say I put it in there. It'll say,
okay.
no. And also this thing will grey out, and if I click on it, it'll say, you know, I've got an input that's not wired, and something is wrong. So if I click on show error, it'll flash and say, look,
okay, that's why
this is problematic. But we don't want that wire there, we want the wire into the file path. And then there's no problems. This thing says your VI is fine. Okay, so we've got this open. Now what we need to do is display this image. So if we go over to the front panel, and if you right click on the front panel, go down to vision, or you might have to click on this drop down thing to see it, but go to vision and then just go to image display, click on it, you should get this really big box and just drop it on your screen. You'll see it pops up in the left pane as well, because this is our representation. Okay, so here we are with this thing. Okay, so we need to do things in some form of real time. So we need to show the image lots and lots of times. We need kind of a delay so that we can draw our box. If we did it right now, as soon as we run the VI, it would stop before we had a chance to do anything. So we need to wire up the image. So now we're actually displaying this image. But we also need to put it in some form of loop. And because we want to wait for an input from the user, we want to choose a while loop. So if you right click on the block diagram and get your programming set up, go up to structures, go over to while loop, and if you left click, you should get this kind of little dotted square, and that's going to allow us to draw a while loop on the screen. So you left click on the screen, draw a box, left click again, and there's your while loop. Okay?
What does it help again?
So a while loop means keep going until it receives input. So the input here, which is a stop button, we're going to manually wire up a stop button. So it'll keep doing this until we say stop.
Okay.
So right now what it will do is this image will come in, it'll come into this while loop, and then the same image will keep getting sent down this wire over and over and over again until we say stop. It's not going to change the image, it won't do any part of this. The only thing it's going to do is run round and round around this box until we say stop. So we need to wire in a stop, so we should do that first. Is everybody
So the image is
good? Okay, so we need to put this stop command on there, else this loop's just going to go on forever. So if you go over to your front panel and right click, go to buttons, and then choose stop button, and then just put it somewhere, doesn't matter where. Okay, and then stop showed up here, just like here. And what we need to do is put this inside the loop. The reason it's inside is if we put it outside and then wire, so if we did this, it will allow you to do it because this is a true false command and it going to the stop button. However, if we're running this and it goes into here, it will keep running this loop with the same value until we hit stop.
May I ask a question? Maybe it's a stupid question, but
Yeah.
if, let's say, you will read only one single image,
Yes.
would you do the same? Or is it, I mean, what is...
No. If you just wanted to show one image
Yes.
and you didn't want to do anything else, then you don't need any user feedback.
No, not show, but maybe you analyze just one single image. What is keep running You know, what do you stop? That I don't understand. If it's a series of images, like 100,
Right.
then you stop at some point.
No, we're nowhere
It's
near
not
that point.
about it, yeah?
You're jumping too far ahead. All we're doing right now is we need to display we need to draw a box on the image, okay? But to allow us to draw the box on the image, we need it to keep running. We need the program to keep running.
Ah, that's what you mean. You stop the program.
Yeah.
Okay.
If we just displayed the image and that was the end of the program, it would just stop.
Okay.
And
I
then,
understand. Okay.
But what we need to do is we need to give ourselves some time to draw this box and do what we want to do.
Mm-hmm.
And the way that we do that is we put a while loop so that it waits for an input from us. So we need to wire the stop button. Okay, so now it'll just keep doing it until we hit stop. We also, so computers run really fast, and Labview uses directly interfaces really well with all the different processors. So if we ran this as is, your computer would slow down a lot because it will use all of its power to keep displaying this
so
image.
We put the trash bin.
No. It uses all of its power to show this image as fast as it possibly can. And you can't see anywhere near the speed that it can run. It will display this, it'll do the loop runs less than a millisecond. And basically your computer CPU will go to 100% and it will really stress the system out. So we need to put a delay in. So we put a time delay in so that we don't work on faster than 30 frames per second. So we don't need the computer to run faster than 30 frames per second. So we need to put a little delay thing in there. So if you right click on the block diagram and go to timing, and we go to this little stopwatch. Okay, you click on that and put that in the loop. And what that allows us to do is say, okay, we don't want to run this loop faster than what we can see. So if we wait 30 milliseconds each loop, we're going to essentially get 30 frames per second analysis time. And we don't need it to run faster than that. For the actual analysis, we can let it run as fast as it wants. But while it's waiting for an input from us, we don't need it to run that fast. So if we hover over this how long to wait, right click and go to create a constant, we can set this to 30 milliseconds. So that now when this loop runs, it starts all things simultaneously. So it pulls this image in, and at the same time it starts this counter. It'll display this image in about a millisecond, but then it'll wait another 29 milliseconds before it does anything again.
So what was this memory thing that you said? It will also slow down if you don't put this trash
If you
bin.
clean it up, we'll do that at the end. We just need, all it is for correct programming, you should destroy everything you create. Okay? Good. Okay, so now, again, we can run this and it will just keep displaying the image over and over and over and over again. And in fact, we can do that. If you just go to the front panel, click on this folder, and then go to the location that you put Celine's images. And then just pick any file, it doesn't matter which one, just choose a file.
But how it will know that it's a series?
It doesn't yet. Just showing you that the VI will work as is.
Oh, but as soon as you set this up, it could be any file. Oh, okay, that's good.
So once you've got that in the path, you can just run the VI, and it'll just show the image. There it is. Then on, you can use all these little tools. If you click on the zoom one, you can zoom in, or shift and click to zoom out. Or basically the VI will run as is. But if you can see, the VI is still running. This little symbol up here, and the fact it says it's running. If the background goes totally gray and you lose this crosshatch pattern, it means it's running. Also, you've got a little pause button too. But like I was showing in the first example, if we click on this little light bulb, it'll slow it down and show us exactly what's happening at this point in time. So if we click on it, it shows us here that we've got, this is reading a false signal each time. We've got data running along this wire showing the image all the time. and we've got this little timer running.
Just one single image.
Yep. It's the same file. As soon as we run this to here, it pulls the same thing in from this while loop each and every time. So all it's doing right now is reading the memory, 30 frames per second. Nothing else. If we stop this, we hit the stop button. The VI stops. This little crosshatch pattern comes back. Okay. So this VI on its own will right now display an image. That's all it does. Displays an image and waits for you to say stop displaying the image. But like I was saying last time, we need to destroy everything that we create. It's just good programming, and it'll also stop you from destroying your RAM by keeping things stored in it. So what we need to do is destroy this iMac. So if you right click on the block diagram, and you want to be going into image management, and then you want to go to iMac dispose, this little trash can, and you click on it and just put it on your screen somewhere. Everybody got a trash can? Nope. So what toolbar are you in? So go to Vision Utilities, Image Management.
Hey Kevin?
Yep.
Can you put the stop button outside the loop later to show the difference?
I can do it now. Well, yes, let me slow it down. So if I do it without, well, in fact, probably more than that. So if I do it like this, what happens is, as this loop's running, like you saw, it will read information from the edge of the loop inside the loop. Okay? So by the time the data gets to here and it's running around here, if I push a button outside of the loop, it doesn't read it because it's not inside the loop. So it will keep running around this loop.
Only read.
Right. So it'll keep running around this loop until this value goes to true. But this value will never change because it won't read anything outside the loop. So if I action this now, it will go indefinitely. And I'll have to essentially break the program to make it stop. I mean, I've slowed this down to be 1 second so that I've got enough time to hit the stop button. But if I kept that or didn't have a timer in there, it'll just keep going because there's no...
Can I run this?
Yeah, so if I run this now, essentially, if I hit stop, it does nothing. It won't do anything. Because it already knows what information is coming from there. Okay, at the start of this thing, it was reading false. And because while we're running it, it will not do anything. It won't do the next element until the previous one has finished. So it will keep running this while loop until it finishes. It won't ever read this button. So you have to be a little bit careful how you do this because right now I don't have a button that will stop it. I have no way of stopping this loop. But because I have this really large time delay, my processor isn't like being really stressed. So I can hit stop at any time and it will stop. Okay. If this wasn't there or it was really short, if this loop executes faster than I can push this button,
which it does.
Which it will do, yeah. Then it will never, the computer will never essentially see me hitting the stop button. It'll just keep running the loop. So, I mean, you can crash the program and you can control it, delete, and destroy, essentially stop the program running. But if you're doing something really complex that's CPU heavy, you might not, it's just problematic. And that's kind of one of the issues with computer coding. You can make your computer do something you don't want it to do. I mean, there's always a possibility. But you only do it a couple of times. And if you try to keep with some of the good practices like this, because even at 30 frames per second, I've got enough time to hit the stop button. I can hit the stop button faster than 30 frames per second. So even at this, I could hit stop and it will still read it. But if you don't have any delay there, it's going to get really problematic. Okay, so does everybody have a way of displaying files? Yes, 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 okay. Okay, so next thing we need to do is we want to not do one image, but we need to do a lot of images. So,
Your garbage?
oh yeah, sorry, yeah, I got lost. I got lost, sorry. Thank you. So image management, put your garbage thing on the screen. There are two options that we can do. We can just wire up this error to this loop and find something to stick it to. We need things to run in sequence, I should say. We have to run this trash can after we've displayed the image. Okay, so we can wire this error to here. And like I was showing in the first one, this is one way of making them run in one sequence, because it won't run this until this is run. But even doing this, there's a chance that we will destroy it before we've shown it. Because right now we have what's called a competition of processes. That the data is going to run along this line at the same speed that it runs on this line. So we might actually destroy the image before we display it. So this isn't what we want to do. What we want to do is route it through the loop. So then it can't do it until the loop has finished. So now this, because it runs in sequence, this cannot start until this has finished. So we have to say stop before it will destroy the image. So now we have no competition. I'll show you how to do it. So sorry. So if you left click on the arrow out, yeah, okay, and then we just kind of move our mouse to the other side of the loop, and then click on the edge of the loop, yeah, okay, you should have that, yeah, and then left click on this side of the loop and go to the arrow in. Okay, now we're running it in sequence. We okay? Okay, so we have two options for telling it. So right now we've just said destroy an image. It doesn't know what image to destroy. So we have two options. We can say destroy this image, which is fine for this example because there's only one image. But once you start getting to Labview, you'll realize that you need to make space in the memory for lots of images all over the place. So if you know you don't need this image again in this program, what you can do is just say destroy all the images I made, because I just want to clean everything up. So the way to do that is if you right click on the top of this trash can where it says all images and just create a constant, there's a little true false switch. If you hover over here, it's kind of saying, do you want me to trash all images? And the default is always no, just trash the image that you told me to trash. But what we want to change it to is true. So if you click on the T value, which now says, once this error line gets to me, in other words, the end of the program, I will now destroy all of the images I created. And that's a much better way of doing it for programs where you're using more than one. Yeah, go ahead.
No, it's just I'm thinking if you don't connect it to that point, but to the exit somewhere.
Say that again.
The yellow
Yeah.
line. If you don't connect it to there.
To here.
Yes, but somewhere else, like outside
Here?
of after the loop.
I'm
Like,
confused.
Where else you can connect it?
This?
Is that the only option?
Well, I can connect it to here or here.
Oh, okay, I see. So it has to be before this loop anyway.
Yes.
Okay.
I mean, it doesn't have to be connected to any one of these elements. I can essentially, I can make an error constant. So just like you can make numeric constants, you can make error constants. It's just an open space that errors are going to come from. A lot of these things are just, because it is still a programming language, we have to tell it, like separate sections of memory for certain things. Like if we're expecting to make some numbers, we have to say, make space for some numbers because we're going to get some numbers. If we're going to expect an error.
No, but I mean, when it reads the image, is in the loop. This place, yeah,
yes.
Exactly. So but you have to connect the trash bin before that it does this. Which is the functioning button here? I mean, is it here where it reads the image, or is it here?
There.
Here. Ah, okay, then it makes sense.
This is just.
I thought it was the other one.
No. So this is just an indicator.
Okay.
So
I see.
if we had
indicator.
yeah, so it's just a visual indicator. I mean, we could tell it to display the numbers, and it would show a big array.
Okay, I see.
It's being so the file is being written to an image here, and then here it's just displaying it. There's no reading of the file.
Okay, I understand. Then it makes sense that you wire it up to the other one.
Okay. So what we need to do is we want to draw a box on this image, and we need to read out the region of interest. Okay. So what we need to do is right-click on image. Okay. We need to go to create. We need to go to property node. Okay, then you want to scroll down until you get to ROI, or region of interest. Okay, click on that and drop it somewhere on your screen. And if you get auto tagging, delete it. Okay, so everyone should have this little ROI thingy. Let me open up. So if you go to help and show context help, sometimes it's useful to keep that active, because when you hover over things, it gives you information about that object. So right now we're hovering over this ROI, and up here it says this is a property node. This is a cluster of 2 elements. It contains this data, and this is how they're sectioned out. But what we want to get out is this global rectangle. We want to find out where are boxes that we've drawn. So it says this is a cluster, and we need to get the first part of the cluster out. So we need to right click on the front on the block diagram, and we need to go to cluster palette. We want to go to unbundle. We need to separate out this cluster. So if you click on unbundle and put it close to.
All the time when I click the right, I have something different appears, like functions or something like this. That's why I'm lost.
No, it's fine. Just. So what do you see when you right click? You don't get this? Okay, so go to cluster and then go to unbundle. Okay, and then just drag, click and drag that to the screen. And it should look like this. It should be blank in both the top and bottom, because right now it's just waiting for input. And if you just wire the ROI into it, it should change to the 2 things that are within this cluster. It automatically knows.
What are you separating actually from each other?
We need to know where this rectangle is. So we're drawing a region of interest, and we need to know where this box is. So there are lots and lots and lots of different bits of data that can be held within the region of interest key. But because all we need is this box, and we're going to do everything else externally, we just need to get this global rectangle out. So what we're doing is we're opening up this cluster. So once we open it up, there are 2 things. There's a global rectangle, and there's something called contours, which is more or less everything else. If we wanted to, we could go to cluster and we could unbundle the rest of it. I mean, if we click on here, oops, there should be a bundle. Oh no, it's an array of cluster. Okay,
Is
so
is rectangle only the definition of it, or you can draw a region of interest of any shape.
The rectangle information that it gets out is essentially the four corners of the region of interest. If that region of interest was something like with this guy, some wacky,
Okay.
multiple shape thing, it would essentially still give just the four corners, unless you went into the contours and picked out every single point. So if we go over to here, you'd be able to see that, look, there is an option to pull out all points. And for things where you've drawn some wacky shape, you have to pull out the points. Unless you just want the outer box, then you can use rectangle. But if you want all of the individual points, you have to pull out all of the data points individually. I mean, they're all in there. It's just, for this example, you don't need them. The only thing we need is this box that we're drawing. Okay, so we have this global rectangle. And like just from the first example, we need to change it to a different format. So what we're going to do first of all is drop on the light bulb so that we know where we're at. We're actually running out of time here. Let's do that first then. So we need to go back. On your block diagram you can either go through this one or you can right click on here. Go to Vision and Motion. And this time you need to go to Machine Vision, because this is a VI that Labview uses. And you want to go to Measurement Intensity. And then you want to click on the light meter rectangle. And you want to put that on your screen. Okay. Yeah? Okay. And just as an example, if we didn't know, we hover over here and it says, up here it says it's expecting a rectangle. But if you look, this is a different color and different type than what this is. This is a blue, thin line. And this is kind of a browny orange thick line. So you instantly can know these are not going to work. If we grab this and stick it into here, it's going to say no. And if you hover over it, it'll tell you why. So it's like, look, I think there's an error here because, they're a different type. So what we do when we know they're a different type is we need to find out, okay, what is this rectangle? What format is this in? So if we click on Detailed Help, it'll pull up information about this particular function. And if you look here, it says, okay, this thing, that rectangle, well, this contains a cluster of these four things and a rotation. Everybody see the help bar?
Almost.
Almost, that's fine.
My something was different.
You're fine. Yeah.
Okay.
Okay? Okay, so right now this little brown thing here is saying, look, there's a cluster of 5 elements. They're all different types. Well, not all. There's 2 different types within this cluster. Okay, so if we go back to our block diagram and hover over this one, it says the global rectangle is a 1D array. So we need to convert a 1D array of 4 elements to a cluster of 5 elements. And the way that we do it is we have to index the array at each of the 4 locations for the x1, y1, x2, y2. And we need to convert that information into a cluster of 5 elements. Okay, get the idea? So what we need to do is we need to build a cluster and index an array. So right click on here and go to the array palette. Array palette up there. And go to index the array. Yeah, if you click on there and drag it to your screen, you should get a box that looks like this. And right now, it's quite simple looking. You got one?
What was it? Array and?
Index array.
Index array. Okay.
Yeah? You got one of those on your screen? You're clicking like a million clicks here.
Yeah.
Okay. Connect global rectangle to this. So essentially we're now We're now reading this array into here, and we need to index this array at 4 points. So if you grab the bottom and pull it so that you can put 4 values in here. Yep. Okay, now if you right click on each one of these and add a constant. So Labview, as we mentioned before, always starts at 0. So we need to put 0, 1, 2, and 3 as constants in here. So you right click, go to create, constant, 0 is the first one. Right click, create, constant, the second one to be 1. Right click, create, constant, third one is 2. Right click, create, whoops, that was control, not constant.
What constant is that? Like, what does it mean, constant?
We're just giving it a numeric value.
You mean what?
It literally just means 2. It's just a number. It's a value.
Okay.
This is a 1D array, so it's just like in any Labview, MATLAB, whichever. An array is just the sequence of numbers. It's in one dimensional. We need to split this into individual elements. So you do what's called indexing the array, saying, look, I want the first element, the second element, the third element, the fourth element. If this,
and each element corresponds to each pixel, or?
Now, each element corresponds to a different element of the array. So in this thing, it says it's a 1D array. And if we go in here, it'll tell us it's got 4 elements. Okay, it's got x1, y1, x2, y2. There's only four coordinates make up a rectangle.
Okay.
So we know there's only 4 coordinates, so we pull in all four index parts of the array. So if we actually went to, look at index number 4, there would be nothing in it, because there is nothing in the 4th position of the array. The array isn't that big. Okay, so now we have some elements. These are the values which come out from these points. And we need to put these into a cluster so that this can read it. So if you right click on the screen, go to cluster, and we now need to bundle things together. So if you click on bundle cluster, put that in front. We can delete this, make sure we're in the right order. You need to make it big enough so that you can put 5 things in it. 1, 2, 3, 4, 5, yep. And then you need to drag across them in order. So the first one goes to the first one, second one goes to the second one, third one goes to the third one, fourth one goes to the fourth one. Okay. And then the 5th one is a rotational number, which is in double point precision. So we need to make a double point precision constant that just says 0, because we don't want it to be rotated. We just want to use it as is. The rotational parameter is just because this allows you to put rotated rectangles in there. So we need to right click on here, go to create. It's not going to let us do a constant. Okay. If it ever doesn't let you do this, so we want to create a constant, but what it's telling us is that there's too many options for constant in this. There's too many things that we can wire into a bundle that we can't tell you what a constant is. It could be a string, it could be a number. So we need to make a numeric constant. So if you right click on block diagram, go to numeric, and then go to numeric constant. Yeah?
Yeah, I have just a problem with the it's before. It's just to create one more, If I want to do like this.
Yeah, it's because it's already written.
So where it is?
So delete that.
Okay.
So Control B gets rid of broken wire.
Okay.
So if you hover over it, it's saying like that one's already written somewhere.
Okay.
This is the available one here.
Put it
So,
here.
you can
Put it here.
right click each one of these
Yeah.
lines. As soon as I can right click on the line. I'm going to clean up
So what
wire.
does the 1,
I'll tell you all the
0, 2,
wires
3 mean?
Okay.
Set the value.
It's actually,
Which that is choose an area.
yeah.
Yes, there's the one
But
zero.
as it's
That
the
one's
property
white.
of Labview that
Ah,
it
yeah,
starts
yeah.
always from
Ah,
0.
That's
So if
really-
it's
one
4,
really
it
good
should
white.
be 0, 1, 2, 3. If it's 5, it should be 0, 1, 2, 3,
Oh,
4.
white is fine.
Just the set the start number.
It should start, it doesn't start from 1, it starts from 0.
But you already got one, so
Start
you have
from
to
zero.
break
Yes.
1, 2. See, because that should be 1.
So the one is the
So
X
1 right now is wired into the 1. So
one
I
zero.
didn't get it very clear. I
Okay.
got
What's that?
the question about constants.
The
They're just-
1, 0, 2, 3. For example, there is a rectangular area we choose in the image.
Right.
So what does the 1, 0, 2, 3 mean in this kind of
So-
region?
Right, so you've got an array of numbers. So any rectangle requires 2 data points.
Yes.
That's all. You just
Yes.
require 2 data points to define a rectangle.
Yes.
So top corner, top left, bottom right.
Yes.
Okay, so you have x1, y1 is
Mhm.
the essentially the top left, and x2, y2 is bottom right. Okay, so whenever you draw a box, those are the 4 data points that it uses. Those are the 4 number sets. Once you have these, this rectangle function essentially puts them in a 1D array. So essentially treat it as a number with commas between. So it puts, let's say you know you have something x1, y1. Let's say it's 1, 1, and x2, y2 is 3, 3.
Yes.
Okay.
Like that.
So then in the array, it has 1, 1, 3, 3. That's a string of numbers. Just says 1, 1, string 3, 3. And you will have to say, you have to then index the array. So you're saying, look, I need to pull out these numbers individually from this 1 string array. So then what this is doing is it's saying, look for the number before the first comma. So that's that one. And then the second one, which is position 1, it's saying, look for the number that's after the second comma, before the second comma, which is that one. And then, you know, so 0 means look for the first element, so before the first comma. 1 means look for the second element, or before the first comma. I mean, it's second comma. It's basically just, you're taking a number, putting it into something which
Okay.
defines an array, but then you need to get each number
Okay.
out. So it's called indexing the array, meaning I need to
But
pull them out.
because you define the rectangle with 2 points. What
It's
if,
always
for
defined with 2
example,
points.
yeah, but what if it was, for example, let's say for another application, it was a pentagon.
Right?
Then how many constants you put in there?
No, because this is a rectangle.
Yeah, but I mean, what if it was not?
Well,
If you
this-
need to
this-
define 5
right.
different points,
Right.
how many constants you would have there?
Well, you won't be able to use that function
Okay.
because this only pulls out a rectangle.
Okay.
If you want to pull out some shape which is, so even if you drew a pentagon, let's say you had a nice big pentagon, then what it would do is the rectangle would fit the edges of the pentagon. So if
Okay,
you
then
said,
you still need 4 constants.
right,
Basically.
so it'd still be
Okay.
four. If you had like some wacky, funky shape, and you said, tell me the global rectangle for that, it would be that.
Yes, okay.
If you wanted to pull out this information from a funky shape, like I was saying, you have to pull it out from the more complex one.
Okay.
So you have to open this one up. You then have to pull out all of the data points individually. The only thing that you get with this first one is the very outer border of the region of interest. Okay, so does everybody have, they almost bundled up? Yep, okay. So right click, go to numeric, and create a numeric constant. Did everybody do that? Yep, okay. So now wire this numeric constant into the bottom of the cluster. You okay? Okay, so if you now right click on the numeric constant, go to representation, and change this to DBL, or double precision. It should change color.
And what does that mean?
So it's because when you're using inbuilt VIs, they want certain information. Okay, so this VI wants a rectangle in this format. If we have this format wrong, so it might not give me the error here because it's got a cluster. I mean, I can change it and see. No, it's not bringing up the error. But if it's saying something's wrong, as it's running, it might run it. But to do it properly, we shouldn't use it this way. In this example, it might run it. It's saying it probably will run it. The problem is that for angles, it expects them to be non-integer allowed. You know, like if you give it an angle, 22.5 degrees is a fine angle. But you can't have pixel 22.5. Doesn't exist. So when you're talking about, definite objects like pixels or positions, they have to be integers. And if you give it a value that's not an integer, a lot of times, like I was saying, it will try and use it, and it will give you this little red dot saying, I think we're okay, but I'll have to convert something. But because I know exactly what that red dot's due to, it's because it expects to get an angle value, which is allowed to be more varied. The red dot's still there, but it should go away. You're supposed to wire it as a double precision. And if you go to the detailed help too, it says it right here. So look, I'm expecting an I32, a 32-bit integer for each of these values, and a double point precision for the rotation. And if you don't get it, it might run it, but it also might not run. It might say, look, there's an invalid number type when you're actually running it. So because we know what it's supposed to be, we should do it the right way. You can do it a different way, but we should at least try.
I have a question. So it means that we don't want to rotate.
Right.
So we just cannot skip it somehow?
No, because it's expecting 5. So it's a bundle.
Okay.
It's a bundle, and it's saying, look, I expect 5 bits of information. And when it opens it up, there's only 4 bits of information, so it's like I'm missing.
But why it expect 5?
Because the people that wrote this VI expect 5.
Oh, okay.
I know. We're about to finish.
Can I just ask you a question?
Yep.
Yeah. I'm having issues with the stage at my microscope, so I would need to try the other stage.
Yeah.
Do you mind if I bolt it
No,
away from?
you can unbolt it.
Yeah,
That one.
okay,
Yep.
good.
So it's because the writers of this VI
Okay, so
designed it so that you can draw a rectangle, but you can also rotate this rectangle. And rather than coming up with a complex method of looking at all the points and defining each pixel between the points, instead of doing that, they allow you to do it this way, which is much simpler, which is tell me how big the rectangle is and then tell me how rotated it is. It's an easier way of representing
so we
it.
need to define some function which we are not interested in.
So yes, and sometimes you will have to wire zeros.
Yeah, okay.
If it expects 5 bits of information, you have to give it 5 bits of information. Well, let's treat it as an example. Let me shrink this to a 4-bit of information cluster and wire that in. Okay, it now says no. There's something wrong, and it'll tell you up here. It's like, look, there are 2 clusters. You've got a source with 4 elements, and you've got a destination with 5. So we need to change something. Labview, for a lot of these functions, will tell you exactly where your problem is. So we have to stop so then other people can come in. So we're about halfway through. You should watch the video, and what I'll do, because I kind of want to move on from next week, is I will pause this now, or stop this now, continue recording so you can see exactly what I did, and then you can ask questions if you can't find particular buttons, so that at the start of the next week one, if you guys have something that looks like this, we can go and check and see if there's parts that you had difficulty
So we will
with.
not continue from the same point?
We can if people are finding it particularly difficult to keep going.
But the problem is how to find these buttons.
Yeah. Which is why I'll record exactly
Okay.
where to get it.
Okay.
So, and I'll make sure I do it pretty slow, so that you can see, okay, I right-clicked on here, and then you hit pause on your little play and you'll see where all the points are. It's just, we might want to move on from this next week.
Yes, the next team will come in. There are 2 groups.
Only one is
Thanks,
Yeah.
That's good.
Yep.